Now, the purpose, you might be like, why are we dividing polynomials? Why is this even a thing? So these, of course, are the skills that we're kind of leading up to the main part of this chapter. You need to be good at doing synthetic division, long division, when we're going to help find zeros of polynomials. So notice those problems you've worked on the past couple days, they were either factored form or very easily to factor. Well, not everything factors. So that's why we have to have these dividing skills to help us find the zeros if factoring is not a deal. Now, this is fun. Can you remember how to divide this as if you were in 6th grade math? And please don't write the remainder as R whatever. Looks on your faces, I love it. Because oh God, I love it. The process of this is the same for our polynomials today.
What?
I wish I could project the look on Owen's face right now. Oh God, I love it.
Remember, how do you do it?
You don't know how to do
You
it.
don't remember how to do long division?
Okay, so first question you're asking yourself is 43 divides into 87 how many times? 2. And where do you put the 2? Okay.
How long do we have to?
I'm really enjoying this, by the way. Now what are you doing with the 2?
Multiply them together and then subtracting it.
Okay, so 2 times 43.
86. That's what I meant.
What am I doing with the 8?
Subtracting.
Okay, now I'm just going to hold up the truck for a second here. Because again, even though I'm very entertained by this whole situation right now, the process, because we're going to be doing this process with polynomials. So whatever goes on top, you multiply to the divisor, 43, and then you subtract. All right, what's 87 minus 86?
1.
Now what?
Take down the 9.
But before I bring down, here's the problem though. Does 43 go into 19?
No.
So what goes on top? Now what? Now I can bring the 2 down. Now you might need your calculators, because I don't expect you to necessarily do that in your head, to figure out how many times does 43 go into 192. You might need your calculator to figure that out. How many times does 43 go into 192? Avery for the win, she's got 4. You are? What's 4 times 43?
172.
172. And then we subtract. Our remainder is 20. So even though while I'm very entertained by this, okay, 1, it's about the process. Whatever goes on top, you multiply to the divisor, and then we're subtracting. Now, we are big kids now. We are not writing R20. God. How do you write the remainder as a fraction? 20 over.
It's been a while.
It's been a while. That's why I start with a 6th grade math style problem. Okay, so we're going to be writing our remainders in the same form today. The remainder over your divisor. So process is the same. I'm a little scared. Okay, next up. Pulled this right out of the old Algebra 1 files. We can do this is easier. Okay, hit it. What do you got? 3x.
Y squared plus 2.
Because you're just dividing each of these over 5xy and simplifying. Okay. All right. Okay. Oh God, I'm getting nervous. Here we go. Long division's up first, everybody. Now, oh gosh, this looks craziness. So let's talk about, this looks crazy and I'm not going to lie to you, it is. Now, but I'm going to, as always, point out the key important parts to you. So we're talking about dividing polynomials, of course. The key is how you're writing the remainders. We just did this style, meaning this was that 6th grade math problem. You gave me the answer, and then Avery told us the remainder was 20 over 43. 204 and 20 over 43. This is how we're going to write the majority of the answers today. There are a couple problems that are also going to ask you to write your answer in this style. which you're gonna see that here today too. We're gonna do both. So your divisor times the quotient, that's your answer, plus the remainder. If you FOIL these out and add the remainder, you do get your original polynomial back. So this might be, you're probably like, what is this? I've never seen this before. This might be the new part of how to write your final answers. You just have to remember, divisor times the quotient, your answer, and then plus the remainder. And you're gonna see the first couple problems, they ask us to write the answers in both styles. First one you're definitely used to, that's the remainder over the divisor. This is probably something new to you. All right, here we go, do it. Divide by long division. Express the result in each of the two forms shown in the above box, which is above on your notes. Okay, so my divisor, x minus 4. Now, before I start writing in my dividend, just a couple things to always look for. A, make sure it is in the correct order. Highest exponent to the lowest. If it's not, I'll reorder it. 98% of the time they are. If you're missing a term, I'm going to leave some room for that because I don't want to have any like terms not where they should be. Ours is good to go, but I always check. Okay, here we go. So you are ready to put your first term up top. So what you're really asking yourself here, what times x makes 5x squared? You need a 5 and another x. Or if you like to think about it dividing style, I like multiplying, I'm good at multiplying. You're dividing that by x, you get 5x. Now anything that goes on top, I have to multiply through my entire divisor, aka distribute. So I'm going to have 5x times x and 5x times negative 4. I'm going to go through this first problem at a snail's pace, my friends, because you've never done this. Now, before you write anything else, what am I doing with this red line of terms? Subtracting. So I have to be super diligent on my signs today. Both of those signs are going to change. So for dramatic emphasis, I'm going to do it in green. I'm subtracting this, and when I subtract a negative, it goes to a plus. So you have to make sure you change both signs. You're subtracting that whole row, changing the signs. All right, let's see where we're at. Clearly 5x squared minus 5x squared cancels, so I'm not going to write anything. Negative 17x plus 20. And just like our 6th grade math problem, I'm bringing down the minus 12. Okay, so you're ready to figure out your next term to go on top. 2 ways you can figure it out, 2 processes to think of it. I like multiplying, so I just think what times x gets me a 3x? What times x is 3x? Okay, so you hold it. Or you can, of course, do 3x divided by x. Any way you cut it, you come up with 3. Now, any number you put on top, you multiply through the entire divisor. So 3 times x, 3 times negative 4. Again, I'm going to subtract that row of green, aka switch the signs, and I already hear some of you muttering what the remainder is. What's your remainder? 0. Okay, so final answer. Man, I'm going to erase this so I have some room over here. So there's no remainder, so I'm not going to put 0 over the divisor since it's 0. That's really unnecessary. So first I'm just going to put my 5x plus 3 and I'm going to circle it. There's no remainder to worry about. Now, here's the other thing. I'm going to click it back a slide because remember, it wants your answer in the 2 forms shown in the box above. So we have this one. We just don't have the remainder. We have 0 over whatever. That's why I didn't write it. I'm going to do the other form. So the divisor times our quotient, but we don't have a remainder. I'm not going to put plus 0. So divisor, I'm going to put or. Divisor, which was x minus 4, times our answer. No remainder, so I'm not going to worry about it. If you FOIL this out, which I'm not going to bore you with that, if you FOIL it out, you get the dividend. So they just want you to write it in both styles. Is it every problem in both styles? No. Majority of them, you just need the first answer. But there's a couple, and you'll see that this will help us when we have to do some factoring later. All right, let's try some more, shall we? Shall we? Get excited. God, I love it. Okay, divisor, here we go. Now, as always, I check that my terms are in the correct order. It's not scrambled. It's looking great. Like I said, 98% of the time, that's not a problem. Okay. So get it set up. Be conscientious of your signs. All that good stuff. Okay, I like multiplying. So I'm asking myself, what times 2x squared gives me a 6x cubed? What do you need on top? 3 and an x. Okay. And of course I'm going to distribute that through the divisor. Now, if you're working ahead of me, be conscientious of your like terms staying in line. Meaning, yeah, that's 6x cubed. 3x times 1 is 3x, which means 3x. I'm not putting it here under the squared. I'm shoving it down a spot to keep the like terms together. So that was my spiel of the like terms. Just like as always with division, we're going to subtract. So I'm going to change the signs. Got it. Now my 6x cubes are gone. I'm just totaling up what I have left. So I have 0 here. There's still 10x squared in play, so I'm going to bring that down. 1x minus 3x. And I might need the plus 8. I don't know. I'm going to bring it down just so I don't forget about it. Okay, you are ready for your next term on top. What times 2x squared is 10x squared? 5. All right, 5 times 2x squared. Now careful, line it up here. 5 times 1, we all know 5 times 1 is 5. Question is, where are you putting the 5? Under 8. We're going to subtract. I'm going to switch the signs. I'm going to total up. So of course my 10x squareds are out. Minus 2x is still in play. 8 minus 5, 3. Okay, guess what? We're done. That is your remainder. Now, how do you know when you're done? How did I know that that's it? That's my remainder. What's the exponent or the degree of your divisor? 2. Degree of this? 1. It's smaller. So if I'm going to knock a squared down to a first, I'd have to use a negative exponent, and we never want to leave our answers with negative exponents. So I'm done. Now, how do we write the answers? I'm going to do our most common way. I'm going to put my answer plus the remainder over the divisor. Let's do that. So my answer was 3x plus 5 plus my remainder, negative 2x minus 3, over my divisor. So this is the most common. This is you'll be doing majority of the time. Okay, I'm going to click it back just to show you again. And then the other method is going to be your divisor times your answer plus your remainder. So my divisor, 2x squared plus 1, times our answer times the quotient, 3x plus 5. You don't have to FOIL it. Plus, I hope I don't run out of room, your remainder, which was negative 2x plus 3. You don't have to FOIL or simplify or do anything else. Really, this kind of irritates me, that plus and negative. Do you really need the plus on that? No, you could just put minus 2x plus 3, but I'm going to leave it just for now so you can grammatically see I'm adding on the remainder. If you FOIL this and add this and combine all the like terms and do all the stuff, you end up with the dividend, which is going to help us later when we have to get all the factors and all this good stuff, okay? Any questions on that long division? Like I said, you've never done it, so I'm spending more time on our long division. Oh, this is a good one. I like it. Okay, now, I like this one. Divisor, x cubed minus 1. I'm a little nervous. From x to the 5th to 7. Are you missing a lot of terms? Okay, so I'm a little freaked out about keeping my like terms in line. Now, I don't want to get too carried away and put 0x to the 4th, 0x cubed, 0x squared, 0x. I don't want to like add a bunch of stuff because I don't know if I'm going to need it all, but I'm going to, because I don't want everything crammed together and my like terms not lined up, I'm going to purposely kind of put 7 down at the end. I'm going to give myself a little bit of room in case things are not in line. Can you put the 0x to the 4th, 0x cubed in? Sure. But let's not make it any tougher than it has to be. All right, what times x cubed is x to the 5th? X squared. Multiply it through. Got it? And this is what I was talking about. Negative 1 times x squared, negative x squared. I don't want it under 7. So I'm glad I, put a little room in there. Let's subtract, switch the signs. Let's total up what we have left. X to the fifths are out. I've got my x squared, and we've got our plus 7. Now what? We're done. Hey! Because I can't go from a cube to a squared. We need a negative exponent. We never write negative exponents. So that wasn't as bad as we thought, right? So we have to write our answers, of course, in the two styles. The most common style, x squared, our quotient, plus the remainder over your divisor. And then the second style, just again to show you, our divisor times the quotient plus the remainder. Okay, so our divisor, x cubed minus 1, times the quotient. Our answer was just x squared, and then plus the remainder. If you FOIL, distribute, etc., you'll get the original starting problem. Okay, now, long division is long. Unintended, right? Okay, here's the thing. Long division, you can use that to divide any polynomials. Doesn't matter degree, doesn't matter terms, doesn't matter. You can do it. Works on everything. That's why we show it to you. There is also everybody's favorite type of division, once you see it, synthetic. Synthetic is a shortcut of long division. So you might be like, dude, why are we not just doing synthetic? Well, synthetic only works on a specific case, my friends. So, shortcut to divide polynomials. You can only use it when your divisor is a binomial, two terms, degree 1. My divisor on this is x cubed. Couldn't do synthetic even if I had the choice. The cube's ruining it. My divisor squared can only be a 1. Couldn't do synthetic even if I had a choice. Hey, I could have done synthetic on this guy. Your divisor is a binomial degree of 1, x to the first. So that's why we show you both. All right, let's do it. I love this. So it's a shortcut version. You don't have to deal with all the variables. So clearly our divisor is x plus 3. And you've never done this before, so of course I'm going to do the first one super slow, make sure we got it. So the first thing I'm going to do, and eventually you'll just mentally do this, x plus 3 is our factor form. I want to know what would be the 0, aka the solution. You can do that in your head. X is negative 3. Okay. So negative 3 is my divisor. So I'm going to put negative 3 in kind of this little inverted looking division symbol. Now, same spiel. I'm going to make sure my terms are not scrambled, that they're in the correct order. And if I'm missing anything, I'm going to put a 0 to hold the place because I need the like terms together. Well, they're in order. So I have 5x cubed. I just need the coefficient, not the x's. 18, x squared, 7, negative 6. Now leave yourself a row because we're going to have some numbers right underneath it. So leave yourself a row. Draw yourself a line. Okay, first term, the 5, just drop straight down. Anything I write below the line, I multiply with the divisor. So I'm going to do negative 3 times 5, negative 15. That goes in my next open slot. Now, long division we subtract, synthetic you add. I'm going to add these together, 18 plus negative 15. Any number below the line, I multiply with the divisor. So I'm going to do negative 3 times 3. I'm going to add 7 plus negative 9. Any number below the line, I multiply with the divisor. And I add. So, bam, my answer, 5x squared plus 3x minus 2, remainder 0. Done. Okay, how do you get your answer? I know I rattled that off fast. Your last number is always the remainder. A little note there, my remainder. And then your degree of your polynomial here is a cube. You're always down 1 in power. So this is 5x squared plus 3x, x to the first, minus 2. No remainder. Doesn't say we have to write the answers in both forms. Good to go. And once you get good at that, you will just quickly be multiplying and adding, and it's a whole lot quicker than long division. If I did that long division, I'd get the exact same answer. All right, let's practice a few more. Okay, now, again, you're going to get good at this. You can do the 0 in your head. If you solve that for x, you get -2. So that's my divisor. Now, careful. Is your polynomial in the right order? As I see some of us erasing. Okay, so I got to be careful about the order. Obviously, it's scrambled. I don't have to rewrite the whole darn thing, but I need to be conscientious that 8 would be next. 8x squared minus 9 minus 18. Okay. First number always just drops through. Any number below the line you multiply with your divisor. So -2 times 4. And we add these together. -2 times 0. Add. -2 times -9. Add. Again, remainder 0. They're not always all 0. I'm just starting with some easy small numbers to kick it off. Okay, final answer. This represents 4x1 squared. I'm not writing 0x minus 9. Got it. Any questions on that? Everybody loves synthetic because it's a whole lot easier. Now, let's do some with a few bigger numbers here. And notice, yes, our order is correct, but we're missing some terms. So first question, we should be able to just mental math it now. What's your divisor? 6. Now I've got my 10x to the 4th. I have my -50x squared, or cubed, sorry, cubed. I don't have an x squared. I'm always worried about the like terms, so I'm going to put a 0 for the x squared because I want to keep things lined up and I don't want it to get messy on me. I'm going to put a 0 for the x term also. Do you actually have to have zeros? No, but you do need slots for those terms and the like terms. I'm going to put zeros in because I don't have like nice little columns here. You're probably going to need a calculator because we're going to get some big numbers here on this guy. All right, 6 times 10, 60. Add that, that's easy. 6 times 10, add it. Probably don't need your calculator yet. What's 6 times 60? 360. I can add that up. Here's probably where you need the calculator. What's 6 times 360? 6 times 360.
2160.
You got it. Add those up. What's your remainder? Got it. Okay, so let's write out our final answer. So starting with 10, 10x to the what? Cubed. 10x squared. 60x. I need longer arms. Plus 360. And just like we started our original long division problems, I'm going to add on my remainder. Be conscientious here. What is our original divisor? X minus 6. We're putting the variables back in our answer, so I need the x minus 6 for the divisor. Got it. Now, you might be like, why are we doing all this like synthetic division, long division? Remember, we're working our way up to being able to find zeros of polynomials that don't factor. Everything's factored the past couple days. Tomorrow, not so much. Okay, now, remainder theorem. Let's talk about the remainder theorem here, what the remainder theorem is. I find this incredibly wordy for something that's very simple. If the polynomial is divided by x minus c, then the remainder is the value p of c, or like, what does this mean? Let me just show you. So, use synthetic division to find the required values. I don't know if this is quicker or not, quite honestly, but another way to do it. We have done in the last chapter, if I said find f of 5, you know how to do f of 5. 5 cubed, 2 times 5 squared, minus 11 times 5 plus 52. Punch it in your calculator, bing, bang, boom. Okay? Other way you can do it is with synthetic division. Now, they already gave you the value of 5. It's not in factor form. I don't have to change the sign or do anything to it. I'm going to do my synthetic division. 1x cubed. My terms are in order. I'm not missing anything. I'm just running through, doing old school synthetic. 5 times 1, add it. 5 times 3, add it. 5 times 4, add it. Okay. Now, again, I don't know if it's any faster. If you were to put 5 in here for all the x's, okay, like last chapter, if you did 5 cubed minus 2 times 5 squared, plus 52, I can tell you from my synthetic division what the answer is going to be. 72, the remainder. That is the remainder theorem. If you do synthetic division, you end up with the remainder. Is it any quicker to do synthetic or to just pop 5 in for x? I don't know. Probably not any faster, but just a different way to calculate it. So what I need from you is somehow that you know your final answer is 72. So either make sure you circle it just in your synthetic division, or sometimes I have kids that like to write it up top. I just need to know that you know the final answer is the remainder. Okay? So one more. -4 is our value. It's already solved for. It's not in factor form. It wasn't x plus 4 or anything. Same polynomial, so same coefficients. -4 times 1. Add it. -4 times -6. Add it. -4 times 13. Quick, final answer. 0. Is that any faster than if I get my calculator out and do -4 cubed minus 2 times -4 squared? I don't know. That's just another way to calculate it. So that is what the remainder theorem means. When you divide with synthetic division, the remainder is the same as the function value. Just something to show you with that. Okay, factor theorem. Why are these so wordy? So factor. I'm thinking about, okay, what's it mean to be a factor? Like 2 is a factor of 6. 7 is a factor of 35. 10 is a factor of 100. They divide evenly into the polynomial. So if it divides evenly into the polynomial, your remainder should be 0. 2 divides evenly into 10. 7 divides evenly into 21. So if it says it's a factor, your remainder better be 0 or something bad has happened somewhere. So, for the following problems, use synthetic division to show it's a solution. So right now, I know the remainder is 0. Haven't even written anything. Says solution, it's a factor, all the same thing. I better get a 0 remainder. Blah, 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 and factor completely. Okay, we already have x solved for us. Winning. We don't have to do any sign changes or anything. Careful on your polynomial. 1x cubed, what are you putting for x squared? Yeah, we got to keep our like terms lined up. I'm going to put the 0 to hold the place. We already know the remainder should be 0, or something bad has happened here, okay? All right, 1 times 2, add. Bless you. 2 times 2, add. 2 times -3. Shocking news, our remainder is 0. We knew that was coming in. Okay, now it wants us to, of course, use the result to factor the polynomial completely. So I'm going to recover this. I'm going to recover this trinomial, 1x squared plus 2x minus 3. Key word of the day here, factor. I'm going to factor this. What two numbers multiply to -3 and add to 2? 3 and... Now, before you circle it, that's 2/3 of the answer. Third degree polynomial. I want 3 total factors. So don't forget, you have this little golden piece of info. If x equals 2 is a solution, x minus 2 is a factor. Because if I solve this, we get the 2 back. So it's very easy to forget that original value they give you. Make sure you include that in your answer. Or I just always mentally check. Third degree, I better have 3 factors listed down here. Something has gone awry. Okay. All right, let's try this one. I just thought we should do one with a fraction for fun. I don't know, why not? So 1/2, it's solved for. Got it? Yeah. Remainder should be 0. I'm looking at my coefficients. Hey, everything's there. No zeros needed. It's in order. This is a heck of a good problem. Don't let the fraction scare you. We can all multiply by 1/2, I hope. What's 2 times 1/2? 1. And what's 1/2 times -14? Add. And half at 20, of course 10. I'm not surprised by that because I knew the remainder was going to be 0. All right, let's recover this. 2x squared. 14x plus 3. Now, third degree polynomial. My final answer better have 3 factors listed. Personally, I'm like, I mean, these are kind of big numbers. They're not awful, but I'm trying to make it a little easier on myself. I notice they're all even. I'm going to take a GCF of 2 out and then see if I can factor it down from there. I'm like, oh yeah, I got it. Multiply to 10, add to -7, piece of cake, -5, -2. So yes, I took the 2 out, the GCF. That's clearly not got a variable of x on it. That's not an answer. Just those are. I need the third factor. Don't forget this guy. Now, I'm going to be conscientious how I write the factor for that too, though. Because notice there's no fractions in your polynomial. So I don't want to put x minus a half, because if I FOIL it through, I'm going to have some fractions. How else could you write that expression so you get a half? Elliot,
2x minus 1.
you know it. If I FOIL all of that together, which I'm not going to worry with that, you will get that original polynomial back. Got it. Any questions on that? All right, last one of the day. So basically we're working backwards now in this last problem. I'm going to give you the answers, and you're going to come up with some sort of polynomial, some long-winded polynomial for me. That's what we're working on. Find a polynomial of degree 4. So that means 4 factors. I'm going to write down here. And they give you all those answers. Oh, coefficient of x cubed -6. Well, that's fun news. I'm just going to save that for the end. Let's get our 4 factors written out. Now, if my 0 is -3, the factor would be x plus 3. Because if I solve that, I'd subtract 3, I get -3. Okay, 0. I'm not writing x minus 0, because what's really x minus 0? Just x. Okay, 1. X minus 1. Because if I solve that, I add 1, and then to get 5. We now, right small, have the fun task of multiplying this all out together. This is not a polynomial. Remember, a polynomial is a sum of monomials. I want crazy stuff like 5x to the 4th plus 7x cubed, da, 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 da. Now, does it matter what order you multiply in? No, it doesn't matter. I'm just going to be lame and work left to right, meaning I'm going to do these 2 first. So I'm like, okay, I can run an x through here pretty easily. X squared 3x. I'm also trying to save space. Okay, so let's go ahead too and FOIL these guys out in the back, and let's put our like terms together. So I'm going to have x squared minus 5x minus 1x. I'm going to combine it, and then plus 5. Okay. All right. Now we're going to multiply. We're going to FOIL. There's no shortcut here. It's not very glamorous. We have to FOIL all of this out. X squared, x squared. There's that 4th degree it said we should have. X squared -6x. X squared and 5. Oh, okay, we're half done. Now I'm going to take the 3x through, and then we'll combine the terms. 3x and x squared. 3x -6x. And 3x and 5. Got it. All right, let's combine our like terms. I always like to put it in the correct order too. I like to keep it highest exponent to the lowest, just how I roll. Okay, cubes. -6 plus 3, let's combine those. Then I'm going to do my squareds. 5x squared minus 18x squared. And poor 15x doesn't have any like terms to combine with. I kind of feel bad for them. It's kind of sad news there, 15x, but it is what it is. And we're almost done. We've got this little notarooski. They want the coefficient on x cubed to be -6. Okay, well I can turn this into -6 piece of cake. I just have to multiply it by what? 2. But I can't just multiply one term by 2 and not all the terms. So I'm going to run a 2 through this whole darn thing, and then we'll be done. Finally. So 2x to the fourth, there it is, 6x cubed, 26x squared. I need longer arms, 30x. Got it. So crazy hard today? No. Are some of the problems time consuming? Yes. Especially if you have to FOIL or it kicks off with the long division. Super careful of the signs on long division. You'll hear me say that a lot. Okay. Any questions, any of this fun-filled stuff? I love it.